Welcome to Master Math. Today we're going to talk about the surface area of a cylinder, a pyramid, and a cone. You know what those shapes are, don't you? Well, let's review it anyway. What's a cylinder? Well, a cylinder is like a can. It's got a round base at the top and another round base at the bottom, and its lateral sides wrap around and connect at the back of those bases and also connect the top base to the bottom base. How about a pyramid? Well, you remember the pyramids in Egypt. And a pyramid in geometry is just like that. It has a base, and that base can be triangular or rectangular or octagonal or any of a number of different shapes. And it's got lateral sides, but it's only got one base because these lateral sides come up and meet at the top at a point. How about a cone? Yeah, sure, I'll take chocolate ice cream and maybe some sprinkles. Well, in geometry, we don't get the ice cream, but we get the cone. And at the top, where the ice cream would be at the ice cream parlor, there's a base. And then there's a lateral side that wraps around that round base and meets at a point at the other end. Well, today we're going to try to figure out how to get the surface area of cylinders, pyramids, and cones. And let's start with a cylinder. A cylinder, again, is like a can, like this can of Stan's soup. And you can see that there are really three components to this can. There's a top, you can't see it, but there's a bottom underneath here, and there's a lateral side that runs around the two bases at the top and the bottom. Now, when we talked about prisms, to figure out the surface area, we deconstructed the space. We broke it down into components so we could figure out the area of each of those components and combine them to get the surface area of the entire shape. Well, we can do that with a cylinder too. If I were to deconstruct this can of soup, I'd have a top, that's a circle. I'd have a bottom, which we can't see over here because the can's sitting on its bottom. But over here, when we deconstructed, we see there's a bottom. And I've got a lateral face that connects the two bases. And if I were to straighten that out, it'd look like that. Now, if the problem, or if we knew a little bit of information about these shapes, we could figure out the surface area of the entire thing. Let's start with the circles. If I knew the radius of that circle, I could calculate the area, because I know the formula for the area of a circle is pi r squared, pi times the radius squared. I also know that the circumference of a circle is 2 pi r. In other words, if I multiply 2 times pi times that dimension r, I'm going to find out the distance all the way around that circle. So we could figure out the area of this circle, and we could multiply it by 2, so we had the area of the two bases. Now how about this lateral side? Can I figure out the area of that? Well, if they give me a little bit of information, I can. They give me the base, and they give me the height. But wait, I know what the base is. I just figured it out up here. The base is the circumference of this circle, because this shape is going to be wrapped all the way around the can's top, or the base of the can, and it's got to meet right here at the opposite side, so the distance around this circle has to be the base of the lateral side. So now if they just gave me the height, I could figure out the area of the lateral side. The area would be the base times the height. Why don't you try this one? Here's a cylinder, and they're giving me some information. They're giving me the radius, and they're giving me the height. We're also given the formula for the area of a circle, for the circumference of the circle, and for the area of the rectangle. Can you figure out what the surface area of that cylinder is? hit your pause button, do the math, and then hit your forward key to move on to my answer. Well, let's deconstruct the cylinder in our heads. I can see a circular base at the top, a circular base at the bottom, and a lateral face that connects those two circular bases. And I also remember that the distance around the circles would be the base of this lateral, the sides of the can, if we stretched that out and made a rectangle out of it. Well, let's tackle the circle first. The area of a circle, I know the formula for that, it's pi r squared, and I know the radius, and I know that there's two of those. There's one at the top and one at the bottom. So I could figure out the total area of those two bases by multiplying 2, since there are two bases, times pi r squared. And when I do that, I get 226.08. Now let's tackle the lateral side. There's one rectangle that could be deconstructed from that lateral side of the can. And I need to multiply the base times the height to get the area of that. I know the height is 18 inches, so I plug that in over there, and I need the base. And again, the base is the distance around the can, or it's the circumference of the circular base. So, the formula for the circumference of a circle is 2 pi r. So if I multiply 2 times pi times 6 times 18, I get 678.24. Now it's easy. I just add all those up. I add 226.08 and 678.24, and I get 904.32. Well, how about the surface area of a pyramid? Remember, a pyramid is like the pyramid at Giza in Egypt. Well, let's get a little more symmetrical, easy to use pyramid drawn down here. And this is a triangular pyramid. And you'll remember that a triangular pyramid means that at the base of the structure is triangular in shape. And you can kind of see that this triangular pyramid has a base there, and it's got a side there, and it's got another side there, and there's another side in the back that you really can't see. Well, let's, in our minds, try to deconstruct that shape. I could pull that base down. I could pull this side over here. I could pull this side over to there, and then the back side I'd put up there. So I can see there are 1, 2, 3, 4 sides to this structure, and they're all triangles. And I know the area, the formula for the area of a triangle is 1/2 the base times the height. So if I figured out the area of each of these 4 triangles and added them up, I'd have the surface area of the pyramid. Well, let's try one. This is a square pyramid. And you know what that means? It means that the base of the pyramid is square. And you can kind of see that. You can see 2 sides, and you can kind of see the shadow of 2 more sides. So we've got one base, and it's square. How many lateral sides do we have? Well, if the base has 4 sides, which a square would, then there have to be 4 lateral sides. And we can plainly see that each of those lateral sides is a triangle. So if we deconstruct this, we've got 4 triangles and 1 square. And we could figure out the area of each of those, total them up, and we'd have the surface area of the pyramid. Now, the base, which is a square, is 100 by 100. So the area of the base is 10,000. And each of the triangles, each of the lateral faces, the area formula would be 1/2 the base times the height, or 1/2 times 100 times 87, or 4,350 each. So the total area, or the surface area of the pyramid, would be the area of the base, and there's only one base, plus 4 times the area of each of the lateral faces, or 10,000 plus 4 times 4,350, or 27,400 square feet. Well, how about a cone? How would we figure out the surface area of a cone? Well, I'm here to tell you it's a little bit trickier than the other shapes that we've been talking about. I mean, we can deconstruct this cone, and it'd look like that. There'd be a round base, and then there'd be a lateral side, and that round portion of the lateral side would wrap around the base and join at the back of the base, and it would come to a point right there. And we could easily figure out the area of the circle. If they told us the radius, we could figure out the area of that circle by multiplying pi r squared. But how are we going to figure out the area of this? Well, it's a little bit tricky. They're going to give us the lateral height. They're going to give us that dimension right there, which corresponds to that dimension on the cone. But it's a hard piece of math to try to calculate that. So we're going to use a formula. We're going to use the formula surface area equals 1/2 times 2 pi r, and this 1/2 times 2 pi r represents the area of the lateral face of the cone, plus the area of the circle, pi r squared. Well, let's try one. Let's get the surface area of this cone. And again, in my mind, I'm going to deconstruct it, and I've got a round base, and I've got a partial circle that represents the lateral sides. And they're always going to tell us the radius of the base. And they're also going to tell us L, which is the lateral height. It's the height up the side. So what we need to do is remember the formula, that the surface area equals 1/2 times 2 pi r times the lateral height, or L, plus the area of the base, which is pi r squared. And we need to remember that we're going to use 3.14 for pi. Now it's pretty simple. All we got to do is plug in the numbers that are given us into the formula and do the math, and we'll come up with the answer. Surface area equals 1/2 2 times pi, 3.14, times the radius, 3, times the lateral height, 6, plus the area of the round base, 3.14 times the radius, 3 squared. And when we do that math, we come up with 84.78 square inches. Now you try this one. Hit your pause button, get a pencil, and try the problem on paper. And when you get done, hit your forward key to move on to my answer. Well, let's mentally deconstruct this cylinder. I can see that I've got two bases, and they're both circles, and one's at the top and one's hidden at the bottom. And I can see I've got one lateral side that wraps around and connects those two circular bases. So I can see I've got a total of 3 sides, 2 circles, and the lateral side, if I straightened it out, would be a rectangle. Now, let's deal with the circles. Each of those circles has a radius of 10 centimeters, and there's 2 circles. So I've got to figure out how much the area of each of those circles is. So it would be 2 times pi r squared. The radius is 10, so it's 2 times 3.14 times 10 squared, or 628. Now, how about the rectangle, the lateral face? Well, there's only one of those, and it's going to be the base times the height equals the area, because it's a rectangle. So I know the height, that's 16, And I know that the circumference of the circle is the base measurement of the rectangle, and the formula for the circumference of that circle is 2 pi r. So if I multiply 2 pi r times 16, I'll come up with the area of the lateral face, or 1004.8. Now all I got to do is add those two numbers together, and I get the surface area of the entire shape, 1632.8 square centimeters. That's our lesson on the surface area of cylinders, pyramids, and cones. There was a lot of material here, and I hope you understood it. And you need to definitely go do some worksheets. Go to www.mastermath.info and print the worksheet on the surface area of cylinders, pyramids, and cones. Try your luck on that, and then go back to Master Math and try the quiz on the surface area of pyramids, cylinders, and cones. I hope you learned a lot, and I hope we'll see you again real soon.